All right, so today what we're going to do is we're going to talk a little bit about linear and nonlinear functions. Now we've already talked about functions, and functions are a set of ordered pairs where the x never repeats. Okay, so that's what a function is. But now we're going to talk about whether or not it's linear or nonlinear. Well, linear just means that it's going to form a straight line. So what it means is that you have this straight line of a function, right? So if you're on a graph, it just forms this straight line. Okay? You can write it in the form y equals mx plus b. So that's really important to recognize this. And then nonlinear, well, it doesn't form a straight line. Okay? It cannot be put in the slope-intercept form, which is that. All right? So when we're looking for this stuff, we're going to be looking for, one, is it a function? And then two, does it form a straight line? Well, we're going to be given it to us in different forms. So sometimes they're going to give it to us in an equation form, sometimes they're going to give it to us in a table form, and then sometimes they're going to give us in a graph. So we're going to have to look at all three of those and go and say, does this form a linear function or is this nonlinear? In other words, does it form a straight line and is it a function or is it not? So that's what we're kind of looking at. So when we start getting into this, we're going to have different questions, right? Write which equation shows a nonlinear function? Well, if they give us equation, which one is in slope-intercept form? Now, some of these may not be in slope-intercept form, and you'll have to put them in that way. Most of them that I have seen, they've all been in slope-intercept form when given the equation. Now, what you're looking for is the one that says, which one is nonlinear? Which one does not form a straight line? Well, when we start looking at this, y equals negative 1/2 x plus 1, well, that gives me, this is the form we're looking for, y equals mx plus b, right? That's what we're looking for. Is that it? Y equals negative 1/2 x plus 1, y equals mx plus b. That's a linear function. Okay? Then we keep coming down. Y equals the square root of 6x plus 1. When you initially look at this, you think, well, yeah, okay, that would work. But when you're starting to really get into this, you cannot have the square root here. Be careful with that. Now, if this was just over, say, the 6, then we might have a different deal. But for us in the level that we're on, if it's got that square root in there, and it's not a perfect square, it doesn't work. Okay, so it's got that x underneath there. This right here, this is nonlinear. Right here is our answer, okay? But let's take a look at these others because these others are really good examples of what we're going to see, okay? Y equals x plus 1. Well, what's right in front of that x? Well, that's our little 1 right here in front of it, okay? So y equals mx plus b. That's in slope-intercept form. That works. That's a linear function. And then you look at this one and go, wait, well, that's just y equals negative 5. That's not slope-intercept form. Well, yeah, it is when you start looking at this. Y equals, the negative 5 is our b. Negative 5, and you could write mx as 0x. This has a 0 slope. Okay? This is linear. It's a horizontal line. Now, if this had been x equals negative 5, then we got a different discussion. It's linear, but it's not a function. Okay, so watch that. Watch what's going on here. Okay, so we're going to move on into a different one. Okay. All right, so now we got tables. All right, so the tables are the ones that are going to give you the most problems. We can look at this and kind of pick it out once we know what we're looking for. The tables, they've got a little bit more work involved in them, okay? So here's what we're going to do. We're looking, when we have a table, we're looking for a constant rate of change. First thing we're going to look and see is it a function? Okay, so we're going to look, is this a function? Well, how do you check to see if it's a function? Does the x repeat? So I'm going to go through here, and that's what I'm going to look for, because we're looking for which table shows a linear function. We're looking for the one that is linear, which one has a constant rate of change. Okay? First, is it a function? Well, that's a function. It's a function because the x never repeats. Yep, that's a function. The x never repeats. Yep, and yep. Okay, so they're all functions. But now, which ones are linear? Well, let's take a look here. Okay, we're going to look at the rate of change. So between here and here, it is plus 5. And between here and here, it is plus 2. Okay? This is basically the slope, and you can write the slope as y over x, or the change in the y's over the change in the x's. That's what we're doing here. What's the change in the y's, and what's the change in the x's? So I'm going to take this 5 over 2. 5 over 2. That's the y's, that's the change in the y's over the change in the x's. That's what we're looking at here. Okay? Well, then we're going to go here. Well, here is plus 9 and plus 4. Is that right? 6. Yeah, plus 9 and plus 4. Well, if I put this as 9 over 4, does that work? This does not reduce to this. So this does not have a constant rate of change, therefore it's nonlinear. So we can mark this one out. We don't like that one. So we're gonna move on from that one. We don't like that one. Okay? So we're gonna come down here, we're gonna do the same thing. Again, we're looking for this constant rate of change in between here. Okay? The change between these, plus 3, change between these, 8. So you got 3 over 8. Now we're going to do the same thing. Here to here, here to here. Okay? Plus 10 plus 4. Then I'm going to put that 10 over 4. Wait, that doesn't work either. So I can cross that one out. That one doesn't work. Okay, so we don't like that one. And I'm leaving this here so that you recognize that what we're doing is the change in the y's over the change in the x's. That's what we're doing here. Okay, so here, plus 8, plus 8. Okay, so that's 8 over 8, or 1. Here, 8 and 8. Yeah, 8. Yep, that's 8 and 8. 8 and 8. So that's plus 8. That's plus 8. Here and here, plus 8, plus 8. See how all of these have the same rate of change. And they all reduce, because it's really important that you reduce it, right? It's got to reduce to the same fraction, okay? 8 over 8 gets you 1. 8 over 8 gets you 1. 8 over 8 gets you 1. They all reduce to the same fraction. Sometimes what you'll get is, you'll get this 8 over 8 here, but then over here, you might get 10 over 10, but it still reduces down to that same fraction. That's what you're looking for. So right here, this C, that's my linear function. That one's good, right? That's the one we're looking for. And you could keep doing this, and you could go through, and you could look at this one, okay? Plus 10, plus 1, plus 6, and plus 2. Okay, that's the change. Change from here to here, from here to here to here, and then from here to here, here to here. 10 over 1, and 2 over 6. Those two things don't reduce to the same thing, therefore I can eliminate that one too. Okay, so that's what you're going through here doing. But you're recognizing what's the change in the y's, what's the change in the x's. You're setting them up as a fraction, the change in the y's over the change in the x's, which by the way is slope. It's the slope. Okay, the change in the y's over the change in the x's, that's your slope formula. Okay, so that's what you're looking for. once you get doing this a couple times, this will become much easier. Okay, it's not that bad, all right? But you gotta do it a couple times before it gets that way, okay? Come down here, now you're looking at which graph shows a linear function. All right, so first off, in order for it to be a function on a graph, it's gotta pass the vertical line test. That's where you draw a straight line, and I like using this, where you take that straight line, and as long as it only passes in one spot all the way through, it's a function, okay? That makes it a function. Now, and you can do that with all of them, all the way across. Okay, so they're all functions. Even if they look really close, they're still functions, okay? But then, if it's linear, it's gotta be straight line. Well, that's not a straight line. That's a straight line. That's not a straight line. And that's not a straight line. There's only one here it could possibly be. It's that one. That's a linear function. The others, although they're functions, because they pass the vertical line test, they are not linear functions. Okay, so you got to be able to recognize the difference between linear and nonlinear in order for this to make a lot of sense. Okay, so that's the difference that we're looking for. All right. Again with the equations. Which equation shows a nonlinear function? So which one is nonlinear? Which one does not fit slope-intercept form? Well, y equals mx plus b. A is a function. A is linear. Y equals -5 log x -5. First off, we haven't even talked about logs. That should automatically give you a clue that, hey, that's not something we've dealt with. It's nonlinear. It's that one right there. Okay. Then you got y equals -x. Well, let's write this in slope-intercept form. Y equals -1x plus 0. That is the same thing as this. Okay. These two things, same thing. Y equals mx plus b. Those are the two things you need to be able to recognize that is in slope-intercept form. And then we've already talked about one as y equals 2, so I'm not going to go through that again. But we've already discussed that. So the answer, the one that's nonlinear, the one with the log in it, because you can't have that. Okay, you should notice that. The other way to kind of tell, a lot of times what they like to do is they like to do this. Y equals 2x to the second power. Okay, this right here, that stops it from being a linear function. Okay? If it's got an exponent other than 1 right there, it's not going to be linear. Okay? So that's what you're looking at. All right, so watch that right there. Let's see here. What do we got? All right, so a couple more graphs. Graphs are easy. Graphs shouldn't be that bad. Okay? Which graph shows a non-linear function? So we're looking for the one that's not a straight line. That's your first clue right there. And that is a function. Okay, so it's got to be not a straight line, but it still needs to pass the vertical line test. All right, well, so it's that one, right? Passes the vertical line test, but it's not a straight line. Passes the vertical line test, and it's a straight line. And then those two things are basically the same thing. Passes the vertical line, and it's a straight line. There's your nonlinear function. All right, then we go back to the tables. I wanted to make sure to hit the tables again one more time. All right, so again, you're looking which ones have constant rate of change, which ones don't, and in this case, you're looking for the one that is a linear function, so it's going to have a constant rate of change here. So that's what we're looking for, constant rate of change. So from here to here, again, we want the change in the y's over the change in the x's. Okay, and it really is just the slope formula, right? y2 minus y1 over x2 minus x1. And if you'll notice, this is all I'm doing. I really am just subtracting it out to see what's happening here. Okay, well, the change in these, it's got a +4. The change in these is a 1. It's a +1. Okay, so I've got 4 over 1. That's what I'm looking for. Okay, Do the same thing here, same thing here. This is a plus 2, so I'll put 2 over there. Here, it's a plus 4. That's not going to reduce to the same fraction. Therefore, that's not my linear function. Okay? So I can get rid of that one. You remember the first thing I should have checked was, are they actually functions? Which I should have checked the x's. Or do any of them repeat? So I'm going to do that now. So this is a function. This is a function. Yeah, these are all functions, so it's okay. We're going to keep going. Okay, so what's the change? Plus 2, plus 2, so that gives you 2 over 2, or 1, okay? And then from here, plus 2, plus 2, yeah, and here it is, plus 2, plus 2. And there's my function, there's my linear function, okay? They're all functions, this is my linear function. So that's what you're looking for here. All right, and we could keep doing more of those, but they're all really kind of the same. Be careful with these. I think the equations, not going to be a problem. I think you should be all right with those. The graphs, there should be no problems with the graphs. Be careful with these. Watch the change in the y's and the change in the x's. Once we get comfortable with this, determine whether or not something's a linear or nonlinear function. It's going to be no problem. Because if you have any questions, concerns, let me know.